enter it again and again. Cisco. Hello everyone, welcome back to my channel. Okay, today we're going to talk about a very important topic, and that's VPNs. Okay, FortiGate firewall. We're going to set up actually VPN firewall as well, site to site. But before we do that, okay, we are going to discuss about the theory of VPN. Okay, because that's actually very important. Like I will talk about VPN, how you can implement it in different vendors, like not only FortiGate, like even how you implement it in Cisco router, how you can implement it in Palo Alto firewall, whatever. Any firewall, the concept in the end is the same. It's just a matter of, the only difference is the syntax and the way, the methods, and some terms may be different, slightly different, but the main concept or the idea, it's similar. So if you understand this topic in detail, the theory, you will be able to configure any VPN, any site-to-site VPN or hub-and-spoke VPN, multiple branches easily. So let's start with VPN. Okay, so the first concept that we need to learn about VPN is IPsec. What's IPsec? IPsec is a suite of protocol, okay, that secures IP communication at a network layer 3 by authenticating and encrypting each packet. It's a foundation for most secure network. Okay, it's a protocol that secures IP communication by authenticating or encrypting each packet. That's what IPsec is. Okay, we have another definition here. It's a suite of protocol. You can just reduce like this, reduce the definition like this, make it suite of protocol that secures IP communication, by authenticating and encrypting each packet. It's a foundation of most secure VPNs. Yeah. So these are the main component. ESP, which is encapsulating security payload. It provides encryption and integrity. This is the most used because it has both encryption and integrity. It just encapsulates your payload. That's it. The packet, you just add it adds an ASP header, and which makes it more secure and more encryption adds encryption and integrity. AH, you just need to know about it, but it's not used anymore. It's rare. Integrity only. Authentication header, it's only integrity, because that's the reason why it's not used anymore. It doesn't provide encryption, which ASP does. IKE negotiates key and security associations. Okay, IKE is negotiates key and security associations. Let me show you about ESP and let's see ESP here. ESP header. ESP VPN. Look, so this is basically an ESP header. This is the original IP packet. Now let's open image in a new tab. Okay, so this is the original IP packet. IP header, TCP header, data, right? And what happens when you add an ASP header? You add an ASP header here, and ASP trailer and ASP authentication. So what it does is it's going to provide authenticate and encryption on the header. Okay, that's how it works. And we have two major modes: tunnel mode and transport mode. Tunnel mode encrypts entire original packets used for VPN, site-to-site and remote access. Encapsulates entire packets. Yeah, we have tunnel mode encapsulates the entire original packet, used for VPN site-to-site or remote access. Transport mode secures payload only, rare in VPN. So mostly we will be using tunnel mode, so to encapsulate the entire original packet. So this is how we can also see how the packet will look like when VPN tunnel mode. Transport mode. You can see the packet how it will look like here. Now let's go ahead and open image in a new tab. So the image is not clear, but we can see that this is the original header, right? The original payload. So this is the normal IP packet, okay, without ASP. When we add ASP is added on header and trailer, and then same packet. This is in transport mode. In tunnel mode, you just add the original header is not the original header is not encapsulated. You see, the original header is outside of the ASP header, right? So but here it's adding the original header inside. So that's the difference. And we talk about site-to-site VPN. Before moving on to site-to-site VPN, let's go ahead and let's have a discussion in IPsec version 1. What's IPsec version 1? Okay, this is an important concept, and we have to understand how it works. Let's compare it to a complicated business meeting. Okay, imagine you need to set up a super secure encrypted tunnel to send files. IPsec version 1 does this, okay, in two overly formal phases. Phase 1, setting up a secure negotiation room. Okay, the two computers first establish a secure private conference room just to talk about the real tunnel. They need to agree on how to protect their own conversation. We have two modes. The main mode, 6 steps. Like, it's very cautious, formal introduction. They slowly verify each other's identity before revealing who they are. More secure but slower. Okay, this is slow because it takes 6 steps through all this. While aggressive mode, 3 steps. Like shouting your name and password across the room immediately to speed up things faster but riskier. Okay, this is IPsec version 1 phase 1. Okay, now we have phase 2. Then after we have secured the room, now we negotiate the actual data tunnel. Now inside the secure conference room, they negotiate the final rules for the actual encrypted data tunnel that your file will travel through. Yeah. Okay. Now, this is the issue with IPsec version 1. IPsec version 1 is actually no longer used. Okay, we're just learning about it before moving on to version 2. So the issue with the IPsec version 1 is it's clunky, slow, up to 9 messages total. It struggles with things like firewall, NAT, doesn't handle mobile devices like switching from Wi-Fi or cellular. Up to 9 messages total. Okay, it's slow and clunky. 9 messages means 6 plus if you use and struggle things like firewall, NAT, doesn't handle mobile device. Yeah, these are the main issues in IPsec version 1. Okay, now let's go through the IPsec version 2. Okay, this is the modern way and the most used way. It's like a quick, efficient video call. IPsec version 2 streamlines everything. There is no separate phases, just a simple, efficient exchange. Okay, we have 2 steps. Each has 2 messages. That's it. So it says you say hello. Here are my proposed encryption methods. Let's agree on one and shake on it using Diffie-Hellman. Diffie-Hellman is a key exchange method to create a shared secret. This immediately establishes secure connection. That's it. Remember on phase 1 what we did in IKE version phase 1, we had to go through 6 different steps in order to establish a secure channel before starting to transfer the data through the tunnel, right? But here, all we had to do is we did it in 2 messages. It's faster. Now, step 2, IKE auth. Now, using that secure channel, they say, okay, let's prove who we are with certificate or passwords. And by the way, here are the rules for our first data channel tunnel. Let's start using it now. Boom, done. In just 4 messages, you have both the secure negotiation channel and the first working data tunnel. So that's it. In just 4 messages. So that's the thing. And then if we need, we can create a child SA, which is a need for second tunnel, different traffic, refresh, just quick to. So now let's go to the image, this image, to understand it better, the difference of IKE version 1 and version 2. Okay, this is IKE version 1. You see the messages. The main mode, it takes like 6 messages. SA, proposal, this 3D, AES, all this stuff. And then we have to choose, and then you have to use Diffie-Hellman negotiation, and then auth initiation. So basically 6 steps, 6 messages total. Okay, in quick mode, which is aggressive mode, it took like 3 steps. Both are not ideal, not used anymore. This is IKE version 1. Encrypted key, calculated SA, and DH negotiation all in one. See, it's like it combined all this. SA1 and DH. It's the negotiation, it combined it into two. And you see this one, and the second IKE auth, and we move to this one. So that's the difference. It's just the number of messages that is required to create the tunnel. IKE version 1 is complicated, and IKE version 1 is much simpler, and also it supports NAT and firewall easy, much better than IKE version 1. So secure VPN tunnel. Yeah, build the secure. Yeah, steps 2 separate phases. Often need extra help. Built-in support. Yeah, IKE version 2 has built-in support. So the IKE version 2 does the same job as IKE version 1, but it's faster, stronger, smarter. For any new VPN setup, IKE version 2 is the clearer choice. So basically that's what we are. That's what we need to focus. So you might need to remember like terms like IKE SA init. What it does is propose crypto, does Diffie-Hellman, exchange nuance, drive initials, and IKE auth authenticates peer, basically search exchange identity first. So yeah, this is the main thing you need to understand. And let's move on to site-to-site VPN. Site-to-site VPN connects entire networks, branch, office, HQ over the internet. Permanent, always on tunnel. Creates a secure tunnel between 2 gateways, firewalls or routers. Subnet behind each gateway can talk to it directly. No users involved. So the difference, what's site-to-site VPN? So let's say you have multiple branches. Okay, and you want to connect, you want them to talk with each other. They're on different location. So what's the best way to do this? We can use MPLS like to do this, but it's going to cost us. So the cheaper and less expensive method is, since both are connected through the internet, okay, we can configure VPN, site-to-site VPN, so that both branches can communicate with each other. So let's move on to the practical so we can understand how it works exactly. Actually, I'm going to set up site-to-site VPN right away, and then we're going to move on to the next topic. VPN lab. VPN lab. Okay, I will put here one lab, I'm going to name it site A. Yeah, this one is going to be site B. And let's rename this one, actually make it site A. So okay, next I'm going to use NAT here. I'm going to use switch, normal Ethernet switch, and I'm going to connect this here. Yeah, okay, and I'm going to use also VPS here, just to test pinging, to test both network can communicate with each other or no. And then I'm going to use VPS here as well. And then I'm going to use cloud here. The cloud is in order to access the FortiGate through through my browser. So start here, start this one, start this one, start this one. So this is first branch. And this is the second branch. So we are going to open this one, open this one as well, same time. Site A, PC here. Remove this one because this is actually not. Site A, site B. admin unknown 8005 unknown 8005 admin unknown. Yeah, so let's configure the cloud first, so we can access system interface, delete port 3. Let's do set mode DHCP and enter config system interface. I'm going to configure the delete port 3. Yeah, so it got the IP. Let's do the same here. Set mode DHCP and config system delete port 3 and get. Okay, it's not getting any IP. Set mode DHCP and config mode config system interface delete. Yeah, so we got the IP 152 and 153. Okay, so we can access it from our browser here. Let's put here 2 and here 3. Let's separate it so that we are able to actually we will not be able to do that, because still we have to allow access also HTTP and HTTPS, then only to work. And I'll set allow access HTTP and HTTPS, and you have to click type end so to save the file. Look, in order so that I don't mix both the firewalls, I'm going to do one thing. I'm going to use this incognito for site B and this normal for normal tab for site A. So 192.168.168.199.152. Nope. Wait. 1 second. I just remove this one, and that's it. So it's opened for us the browser. Here it's going to be the same, but it's going to be 1. Not 1, it's going to be 3, I think. 3 at site B. Let's confirm. Yes, it's 3. Enter. So we have opened 2 browser tabs here. So what's next? We can Yeah, next what we can do is like next what we can do is actually, yeah, we have to just decide what IP to set. This port is going to receive IP from the internet by default. Also this port also to receive the internet by default. Okay. However, the internal network, I'm going to keep it like this, .0/24. So that means this one is going to be .1 and this is going to be .2. So we can keep here .1 and duplicate here is going to be .2. Okay. And duplicate this one. This one I'm going to make it /11. Let's make it 11 or 12 network. Okay, just for test purpose. And it's going to be same. Here will be .1. Here is going to be .2. Okay, so delete this one. Yeah, so delete this one as well. So we have 2 now. And this 2 is going to be this forget about it. This is just we are using to access for management purpose. Okay, mostly we're going to focus on this one. Yeah. So let's check what's the IP actually. Config system interface. It needs port 1 and get. So the IP is 192. Control C, and let's add this one here. And duplicate here. Let's see what's going to be config system interface. It needs port 1 and to get. We have here Control C and Control V. So it's actually this one. So this is the IP. Let's go. Yeah, this is the IP of this network. Yeah, of this port actually. Of this port. Okay. Yeah. So what can we do now? Let's start the configuration. Let's start with the basic configuration of the PC, the VPS. So we can just, yeah. So IP 10.10.10.2 255.255.255.0, and the default gateway is going to be this one. Done. And here IP 12.0.0.0 and 255.255.255.255.0 10.1. Invalid host name. It says invalid host name, which is okay, because actually here it should be 2, right? Yeah. So now we've set up the IP. Now let's go ahead and configure the PC, the firewall. Okay, as we said, this is going to be site A, and this is going to be site B. Going to do side by side configuration. Okay. Yeah. Let's go ahead and do it. Admin. Done. Save. Later. Okay. Admin. Yeah. and later. Okay, so we have done this like this. So what do? We go to the VPN. Yeah, so we go to VPN, we go to the wizard. There's two ways to configure this actually. You can use the wizard here, like it will set it up for you. Yeah, it will automate many things actually. It's very simple to configure it through the wizard. That's the one advantage of like using the benefit of the main benefit of FortiGate VPNs. It's very simple to configure it. Okay, you can configure site-to-site, hub, spoke, remote access, but let's do it through custom, just for the first. No, let's go ahead and do it through site-to-site. Okay, because actually we went through the theory, we don't need to go through it again before. So let's do site-to-site VPN. This is how you're going to configure it in the real world. We'll go through the name. You can put here site A. Okay, and you leave everything as default. Okay, you have an option change this, but it's better to keep it as it is. And yeah, if the remote device is FortiGate, so no need to change this as well. And next, the remote IP address is the IP address of this IP. So all you have to do is just copy this one. Okay, Control C and paste it here. So this is the remote IP address. The outgoing interface is port 001, correct? And here we can use the pre-shared key. Note this has to match on both. So let's go ahead and type Cisco 123. Okay, and let's do the same thing here on the site. This is site B. Okay, and then I'm going to leave just everything as it is, and I'm going to type the remote IP address, which is this IP address, right? And go to JNS3 and check this one. This is the IP address. I'm just going to paste it here, and I'm going to type the same IP address here. Okay, the same pre-shared key. This key should be similar. Okay, and the port is also there. And next, and there is an option here, dynamic DNS, but here this is used if you have like let's say your public IP always changes. Like you can use dynamic DNS instead of using the IP, the public IP. Okay, there is an option dynamic DNS here. Anyhow, let's go next. We are going to go next. So now let's add the local interface, which is yeah, the local interface is going to be the internal interface, which is port 2 that's connected to the PC, right? And the local subnet is going to be 10.0.0.24 for our internal network, right? The remote subnet, we want to access 12.0.0.0.4. So yeah, that's it. That's all we have to do here. We click next and it's done. Okay, the following settings should be reviewed prior to this one, and when you click create, it's going to be created. VPN has been set up. Let's do the same thing on the site B. The local interface, which should be only port 2. Okay, the local subnet, which is 12.0.0.0/24. The remote subnet is going to be 10.0.0.0/24. And next, create. We have set up VPN here. Site-to-site VPN here. Okay, if you want, you can go ahead and see the channels, the channels tunnel list here, side A, side B. Now it's down. You see it's down here, right? So we can bring it up by going to dashboard network. When you go down, like you'll see IPsec here, right? So now to make it, but all you have to do is just click bring up. It will bring up everything. Okay, now it's up, right? And I will do the same here. Go to network. I will go down to IPsec VPN, and it's actually up. It's up. So there is nothing that I need to do. But this is the benefit of the wizard. It's going to configure for you also the policies. You see this one? Automatically it's configured. These are the VPN policies. Automatically disabled, configured, like from port 2 to site A, and from site A to port 2. Yeah, we've configured. They have configured port 2 is the LAN. Okay, any traffic that's coming from the LAN, it's going through into site A, which is the VPN. And site A is created by the VPN. Actually, it's the VPN. The source is going to be the site A local, and site A remote is the one that we specify, right? Yeah, and schedule always, service all. And one thing that we did, that it did, is disable NAT. We have to make sure to disable NAT on the policy. That's it. That's about it. And we have to also make another policy for inbound. Site A to remote. That was from remote to site A, right? This one was from VPN site A to. This was from port 2, from inside to the site A. It's from site A to port to inside, opposite. So incoming interface is site A. Okay. Outgoing interface none. Site A remote, from remote to local. Just yeah. The same idea. Just reverse this one, see? Yeah, it's just reverse this port from inside to this. So the same thing it has in. Also, there is one more thing it creates. It creates the BGP. Not BGP actually. Static route, I think. Yeah, it creates the static route here by default. Okay, by itself. It created a static route to go to site A remote. Site A remote. Go through the site A administrative and site A enabled. Yeah, so it created a static route to go to this gateway, which is on the other side. We have to this site A interface. The same thing in this branch as well. So now, what we can do to make sure that the VPN is up and working? We can just ping. We can open GNS3 here. Okay, open both PCs. Okay. Okay, I'm going to ping this one. But before pinging, we have to make sure that we've set the interface, the default gateway here, because I didn't actually. Let's go ahead and set the default gateway on port 2. Here it should be 192, no, it should be 10.0.0.1/24. Okay, and here it should be 12.0.0.0/24. Dot one, actually. This is going to be dot one. Okay. So we can also add the roles here. Port 1 is going to be the 1, right? Okay, and port 2 is going to be the LAN. Port 1 is going to be the 1, and port 2 is going to be the LAN. So now let's confirm that the VPN is still running. Go to network, IPsec, it's up, and we go to network, IPsec, it's up. So let's go ahead and ping. Ping from PC1 to PC2. This PC ping 12.0.0.2/t is pinging, and here ping 10.0.0.2/t. So this is how we set up side-to-side VPN. Now both sides can see each other, can ping, can do anything. So this was the first topic, side-to-side VPN. And the next topic is going to be about ADVPN, which is just an important topic. Okay, yeah, which is a very important topic actually. But let's just talk about the theory before moving on to the practical. So so what this is good only, but if you have like two branches, right? What if you have multiple branches, okay, and you want all these branches to communicate with each other? You want all the local networks to communicate with each other. How would you do that? We will use something called hub and spoke. Okay, the idea of hub and spoke is like you will have one hub on the head office. Okay, it's basically the central router or firewall. This is main router or firewall, and you will have spokes on each branch. Okay, hub and spoke. Hub and spoke. This is the one. So this is basically how it works. Hub and spoke means open image on the new tab. This is it. So you'll have one. This is where the head office. Let's call it VPN. Open image at the new tab. So this is not, the quality of the image is not really. But you get the idea. Like, let's say this is the main office, okay? These are the branch office, 1, 2, 3, all these branches, okay? You want all of them to communicate with each other. How would you do it? You'll put one powerful, strong router or firewall in the main branch. We'll call it a hub. And we'll put a spoke, say another router or firewall on each branch. Okay, we'll call it spoke. Okay, so how it works is, usually the details on how it works is that the spoke will have all data, okay, will go through the hub and pass through the hub. Okay, this is the concept. Okay, let's see. Let me show you how it is actually. Hub and spoke works. There are three different ways how it works. Okay, the first method is like this way, like I explained to you. Like from here, let's say any local subnet from inside this branch wants to communicate to this branch, okay, or this branch. So how they can do it is like they have to go through all the way through the main office and go to through the main office, then they will reach there. Okay, same goes to all other branches. There is a drawback actually on this. It will overload the main hub, main router. Also, it's inefficient and ineffective. Okay, this is the first way. Okay, then they identified that another way. Also, it's slow. They found another way, better way. You can add spoke to spoke tunnels between the branch office. Okay, so that they can communicate with each other without going through the hub. But again, this is not scalable. If you have multiple branches like 30, 40, 20 like this, you're going to set up spoke to spoke interface channels for through each branch, which is going to be a full mesh network, right? It's complex configuration and it's not scalable. Okay, then we found a third solution. Okay, these are the common problems they will address. Okay, in a classic static hub and spoke IPsec VPN, okay, every branch spoke only has a permanent tunnel to the central hub. This is what I told you, right? Any communication between two branches must happen through the hub. These are the issues: extra latency, especially bad for voice, video, file share between branch. It makes it very slow. Wasted bandwidth at the hub. Hub becomes a bottleneck. Higher hub CPU performance, load terminating and forwarding interspoke. Poor user experience, distributed application. Okay, the ideal end goal is the same for all three. Achieve efficient any-to-any close, while keeping initial configuration simple. Manually configuring the tunnels, So the concept is the same for this. You just have to make sure you understand the concept actually. Okay, so start with easy hub and spoke based topology, minimal config. Just point to a hub. Use the hub as an intelligent facilitator to learn about all spoke. Okay, when spoke to spoke traffic appears or is predicted, the hub helps the spokes discover each other. Okay, spokes initiate, negotiate, and build direct on-demand tunnel shortcuts between themselves. Routing protocol, usually OSPF and BGP, prefer direct path over this. So this is the solution that we have for our previous problem. Instead of creating manually tunnels between each branch, which is not good for scalability. Okay, and we said that there is a better alternative, and that is called ADVPN for FortiGate firewall. Okay, this is it. ADVPN. So what it does is basically it's going to instead of it's going to first the spokes or the branch, it's going to encrypt the packet, send it to the hub, and the hub it's going to do a shortcut offer. Okay, then it's going to send the spoke is going to send again a shortcut query, and then the hub is going to forward this. Once this is done, it's going to send initially the hub is going to act as an intermediary between the spoke, both the branches, right? But only to introduce themselves to each other, to help in the introductions initially. Then it's going to form a shortcut negotiation and encrypt. Like they will start communicating with each other without the need for a hub. Okay, the hub is only going to facilitate the introduction between them. Okay, using these terms like shortcut, offer, it's going to forward the data, forward the shortcut reply, and shortcut negotiation. So that's the idea. Like initially, it's going to facilitate the introduce both the branches to each other. Okay, using shortcuts, queries, and replies, and then they will negotiate. They will be communicate with each other without the need for the hub. Every branch spoke only has permanent tunnels to the central hub. Yeah, so that's the idea of ADVPN actually. That's the concept. Like, yeah. So let's do it in the lab so we can understand how it works. Okay, I'm just going to add another FortiGate firewall here. Okay, I'm going to keep everything the same. I'm just going to connect FortiGate firewall here. And I'm going to add the VPS here. Start, and then I'm going to add the cloud to access it. Okay, so start this one. Okay, let's continue with this port. Admin. Need port 3. No, actually, let's go ahead and exit and config system interface. Delete port 3. It's actually port 1. Now port 1 will get the IP automatically. Port 3, we should set it set mode DHCP. Allow access HTTP, HTTPS, and so config system interface. Edit port 1. I'm going to get the IP here. I'm just going to copy this one. Yeah. Duplicate, paste it here. Yeah, so we have done here. And the network duplicate is going to be 11. And remove this one. So this is going to be site. Let's configure this one, rename it, make it site C. So we have 3 sites here. Okay, site A, site B, site C. Let's give it the IP address. We need to add address 11.0.0.2 255.255.0 11.0.0.1. Okay, for this, the third site, I'm going to use the let's see the third site, site C. Yeah, I'm going to end this one. Okay, I'm going to go config system interface. Yeah, port 3, I'm going to name it get 199.154. So control C, put it in separate browsers. I'm going to use a different browser for this. Admin. Later. So that's about it. We have now 3 routers enabled, 3 firewalls. We can go ahead and remove the site VPN. Actually, we don't need it now, right? Because we just want to test the down entire tunnel. Yep. And VPN IP tunnel, and remove it actually. Or just leave it down. You don't have to remove it actually, just keep it down and it's fine. Admin. Unknown 3005. Okay, let's go to the network. It's actually down by default because we just put that one down. Yeah, so let's go ahead and configure the site-to-site VPN. But before doing that, let's go ahead and give the interface IP. For this one, it's going to be 11.0.0.0.1, right, /24, and let's call it down here add the HTTPS ping and all that stuff, and physical, this will be LAN, right? So first one will be 1, and that's about it. Now what we need to do from our side is, like, now we need to configure create a new tunnel. Okay, we're going to start with hub and spoke configuration. Okay, hub and spoke VPN will be set up using auto discovery with BGP as routing protocol. We'll have one hub, yeah. Let's configure the hub here. Call it hub A. Okay, next. And so we're going to make this one as a hub actually, or we can make it, yeah, let's make this one as a hub. The first one is going to be the hub. Okay, and then here the incoming interface, we're going to call it the incoming interface is going to be port 1, right? Yeah, the 1. And the pre-shared key, let's put Cisco 123 just for the sake of testing. And this is the tunnel IP and the remote IP. This is done actually by automatically generated by the FortiGate. We'll keep it like as it is now. Next. And actually there is one setting. No, okay, let's keep on doing this. Okay, and we are going to have a local interface, going to be port 2, of course, this network, internal network, and we can add as many spokes as we need from here. We can add here. Now we have 2 spokes, right? We can just put here 2. Both will have different IPs here. And next. Okay, you can create it like this. Once it's created, okay, you will have an option here which will make your configuration very simple. These configuration keys are meant for one-time use. Automatically configure some VPN tunnel settings on your spoke FortiGates. Okay, now I have 2 spokes, right? So instead of manually keeping configuration the same way, all I have to do is type it in the notepad. This is for spoke 1. This is for spoke 1. Okay, and the other one is for spoke 2. I'll just copy this one and this one and put spoke 2 down, paste, put it for spoke 2. Okay, now we can go ahead. This is done, right? Let's go ahead on the other FortiGate firewalls. Let's go and create tunnel here. It's going to be a spoke, right? It's not going to be a hub. It's going to be a spoke. So I'm just going to type here spoke 1 for the sake of testing. And you can enter the configuration file here, key. Like we can just put here for spoke 1, this is the one, right? All I have to do is just copy this one and paste it here. Apply. Configuration applied, and you click next. Everything is the remote IP address is 152. We just add the pre-shared key, Cisco. Okay, and just let's confirm about the remote IP address, which is 152. 122.152. Okay, yeah, so yeah, correct. So next, this is the tunnel IP, and tunnel next, and it will create BGP. Okay, in BGP we have something called autonomous system. Okay, like autonomous system is like area in OSPF. If you remember, we have multiple routers in CCNA. We took like an example, like we put multiple routers, we put them in the same area, like area 0. They share the same the link state database, like they share their routing tables. They all have the same routing table because they share the routing table. Like this is the same idea of autonomous system. It's the same idea but at a bigger scale. Okay, so this is an autonomous system. Local interface is going to be port 2, of course, and next, and that's done. So VPN has been set up. Show tunnels. So this is done. Let's go ahead and configure the third tunnel, which is here. Admin. 1, 3, 5. So we will just go ahead and go to the VPN IPsec tunnels and create new tunnel. We will name it hub and spoke. This is spoke 2. Spoke 2. This is going to be a spoke. All I have to do is go to this one, just copy it and paste it here, and we have outgoing interface which is port 1. Pre-shared key. Let's go. Actually, the remote IP should be 1 second. We should apply this one first. It's applied, and yeah, once you apply it, it will automatically actually do this, so you don't have to and VPN configuration. Okay, once we set up, you can go to network and see the IPsec here. This the tab, and works fine, right? The VPN is actually set up, and to test we can just ping from this to this and this. Ping to 12.2. I think I know the issue. Let's see. The hub of ping.11. Yeah, the issue might be from the site 1. Let's try to ping here. Let's see if it's even. Yeah, we have the IP ping. Yeah, it's pinging fine. And let's try 12.0.0.2. Yeah, it's pinging fine. I wasn't able to ping from the hub to the spokes for some reason. But I can ping from both sides. Let's go ahead and try from here. Ping. Yeah, I can also ping the hub. I can ping also the 11.0.0.2. So that's about it. So basically that's how we can configure IPsec VPN. I mean hub and spoke IPsec VPN. So we will talk about we need to talk about SSL VPN as it's remaining, and we'll see about routing protocol and VDOM in the next session. Basically this is the idea of the VPN. Thank you for watching. See you on the next session.